In our previous video, we talked about network graphs or graph models. You can use network models, graph models. So with our nodes and edges. So let's take a look at an example of how you would create a network graph and then use it for analysis. So recall that a network graph consists of nodes. These are individuals or events, and edges, the connections between nodes. We can also indicate direction, how information flows, and we can also indicate weight, the strength of the connection. And you can represent that weight as a percentage. What's the probability you would talk to this person or go this direction? Or we can represent it as the number of times that you talk to that person or go that direction. So let's actually take a look at a Game of Thrones data set that someone has lovely built. And so if you are working along with us, we are at drstephpowers.github.io/BIA. And we are working on the graph or network models that you see here under diagnostic analytics. The idea is to use network models to understand why something is happening. So for example, why is measles spreading? Well, we're looking at who talks to who comes in contact with each other. That's going to cause the spread or proliferation of an illness. If we talk about a rumor, misinformation, why is it happening? Well, it's because some influencer shared it with certain people who shared it with others. So we're tracking the flow of information or materials. We might look at why all of the ships or all of the planes end up at a certain location. During COVID, we had issues where they were all kind of stuck, and so we weren't seeing the proper flow of people and goods across the world. So we can look at these network models to see where the hubs are and the movement of people or boats or planes to different locations. So it helps us with diagnostic analytics. We can also use graph or network models to understand why the organization is functioning the way it is by doing network models with our organizational charts. And we'll do that in the next video. All right, so in this video, let's look at graph or network models. You can click here and get access to the code, which is what you see here. We are going to use this data set called GOT1. It's Game of Thrones Book 1. And what we are going to do is, you'll find this if you click into here where it says Graph Network Models, you will find the file on the left. You can download the file. So somewhere is the GOT file, GOT1, and then you can click on the download button, which you can't see because my face is covering. So let's move my face. All right, so you would click on GOT1, and then you could hit the little download button here, save that to your Google Drive so that you can manipulate it however you want. All right, so we're going to import pandas as PD and import numpy as NP, packages we use all the time. We have this CSV file stored away in our Google Drive, so of course we are going to need to link this particular Python workbook to your own Google Drive. What you're doing is linking your own Python workbook to your own Google Drive. You are not giving access to anybody else. Okay, so link it up so that I can pull in the data set that I want. And in my Google Drive, it's stored in BIBA handbook in a folder called Chapter 8. So whatever folder you put it in is what you put right here. And then if you put in a folder inside the folder, that goes right there. So I'm going to call it in. Now notice this data set has a source and a target. So this individual talks to that individual. The type here is undirected. So you could have a network model, right, that has direction. Here they talk to each other. So we don't have a particular direction because it can go either way. Now, this information here is from book 1. You can find on GitHub, others have created all the other books as well. So if you want to do this analysis for a different Game of Thrones book, I encourage you to just Google GitHub, Game of Thrones. You'll find lots of data sets people have created. Now, notice here the weight. This is the number of times they have talked to each other in that particular book. Okay, so here's the data we need to get started to build our network. All right, so I'm just going to scroll down quickly and show you here's a network. This network is quite busy, so we'll actually create a reduced version in a moment. But what you see here is that you see each circle represents a character in the book, and the lines represent their communication. Okay, so how do we go about building a network graph? So we're going to use network X as NX, and then we need NumPy as NP and matplotlib.pyplot as PLT. So we're going to be manipulating our data, which is what the NumPy is for. Network X creates the actual graph, and matplotlib is needed to actually plot it. Okay, so what we need to do is from NX, that's the network X, we're going to do from underscore pandas underscore edge list. So what we're going to do is we're going to create a list of edges from that table that you've just imported. So we need this table here formatted like this. You really just need the 3 columns, source, target, weight. Okay. And what we're going to do is create an edge list from that table where source is whatever you called the source column. Target is whatever you called the target column. And then the edge attribute is going to be the weight. Okay. So the weights here, we need to turn them into a dictionary. And so we're going to take nx.degree and then our GOT here. So this is our edge list, not the original table, but the edge list. So here we have it all capitalized GOT. And then we need the weights. So we're going to have it create a list of the weights. And then what we're looking for is the max degree. So we're going to take these weights and we're going to look at their values and find the maximum amount. So when we look at who talks to who, we want to know who does the most talking. Okay. Okay. Now I have to load this first, then that to make it run. Now, you can choose inside of network X, there are different layouts, different ways to visualize your network graph. And so this one just happens to be the spring layout. It looks like this in terms of color and the way it's oriented. The idea is that it springs out. I'll just zoom out to this other one. We'll come back here. But the information kind of springs out is what it is. There are other ways to format in terms of the flow and how the nodes are laid out relative to other nodes. So if you want a different looking design, then go Google Network X and you can find other layouts. They have a list of different ones. So we're just going to use the spring layout here. We're going to use this GOT all capitalized, that is the edge list. We're going to use our weights. You can have a number of iterations that you want in terms of where it's going through them. So there is some formatting you can do here in terms of that spring layout. So in fact, while we're chatting about it, we'll just go to the Network X spring layout, and you can see some of the parameters here that we're setting for the spring layout. So if we go back here, there's k equals 4. You can change this. This is how far the nodes are separated from each other if we're trying to deal with lots of data versus spreading it out because all the nodes are on top of each other, making it hard to see things. Now, we said the spring layout was just one of the layouts. There are others. You can see them here: spectral, shell, spiral, I think. So you can try different types of layouts depending on how you want it to look. So there's a bunch of them here. Circular. Okay. So play with that if you want to look differently. Okay, so we're going to use that layout to lay out all the nodes. And then we're going to build our graph. So matplotlib.pyplot. We can turn off the axis because who needs an X and Y axis? And then we need a title. So we can call this Game of Thrones. You can call it whatever you want. And how big do you want that text relative to the rest? And then what we're going to do is create a loop where we go through the nodes. And we need to specify as it draws these network nodes, it's going to pull the information from our edge list. It is going to use our spring layout to choose the positions. Okay. The node size is set by here. It is set by the weighted degrees. And you can adjust this bigger, smaller nodes to make it all fit. So you can make this bigger or smaller, and you can set the color to whatever you want. So again, you can go and look for the hex codes for a particular color. Okay, and then we can also set the edge color. So what color do you want the lines on your network graph? So that's what we're doing here, is this loop through to create those different nodes based on their position, based on their size. How are we laying this out? So you can play with this point too if you want them to be bigger or smaller. You can change the colors. Then what we want to do is we want to draw labels onto this. So we want it to actually tell us who these people are. So we're going to draw network labels. We're going to use our edge list here and the positions. We're going to replace any dashes and spaces, because if we go back to the original list here, you see it says Adam Marbrand with a dash, and it's just removing these here, Jamie Lannister, Tywin. So it actually is a name and not just this hyphenated information that it is in its current form. So that's what this is doing. It's removing some of that was in the original data set. If you don't have that in there, you don't have to worry about that. And then what we're doing is we are looping through. So we are going to here, we are looping through all of that to format it. Okay. And we're also only including those labels. So we're only putting a name if the weighted degrees, if the number of times they talk to people was more than 100. And that's because it gets very busy if we put a label on every single person in this particular network graph. Okay. Then that comes down to, so this was nodes, this is labels, and then the next part is talking about the lines in between. So we're going to loop through the edges. So for E in the edges, we are going to look at their weights, and we're only going to add lines if the weights are more than, you can change this, more than 20, more than 100. You can do that. And then it's actually going to change that width of the line that connects them based on the weight. So we want bigger lines for ones that have more communication. All right, so let's run this. And as we saw before, this is a very busy network graph, right? Lots of nodes on top of each other and lots of lines. So this is a lot of people, and it's really hard to use this to kind of get some key information out of this. So we may want to simplify this down and only include people who have a lot of conversations with others. Okay, so what you might want to do rather than have this is you might want to create a subgraph where you are looking at the weighted degrees being more than 200. So the idea is to take this and remove all the people who you just talked to one time. Okay, so we do that with subgraph. And for n and n weighted degrees, if weighted degrees is more than 200, then it gets to be in this subgraph. Then the process that you see here is the same as before. So we'll just, anytime we had our capitalized GOT in the previous version, we just put in sub G for this subgraph. Okay. And we can clean this up a bit. Again, you can change the size of the nodes, right? We can change that. We can change the colors. But we're just really repeating what we had before. We can change the weights, how thick the lines are. So we can see now we have a simplified version of our network graph. And this allows us then to see who is talking with whom. Now, we talked about before, what do you do with this network graph? Well, in addition to being able to see the communication or the spread of information or people or materials, we can, one, see how information spreads or disease spreads, or we can analyze it in terms of centrality. Who has the most influence? Who is kind of the hub that everyone goes in between to talk? And so we're going to, over the next 2 videos, we will then look at those particular analysis.